Welcome to Chapter 1, Lesson 7, where we're going to compute with scientific notation. By computing, I mean we're going to add, subtract, multiply, and divide using scientific notation. Let's jump right in and take a look at some examples. We're going to start off with a multiplication problem. You will notice I have written here the steps 1 through 4. What I'd like you to do is first write the problem, and then with each step, I'm going to go through and work each part out so that you have an example to look at in the future. So go ahead and write the problem, and then write step 1, multiply the plain numbers. What that is going to look like is you need to find 7.2 times 1.6. The plain numbers are the two numbers in front. Now, for this chapter, we're doing everything we can without a calculator, and we've talked about how to multiply this before. 6 times 2 is 12, carry the 1. 6 times 7 is 42 plus 1, which is 43, so 43. I need a placeholder of a 0. 1 times 2 is 2. 1 times 7 is 7. And when I add these pieces together, I get 2, 5, and 11. Now I have two numbers that are behind a decimal, which means I take my decimal on the end and move it 2 spaces in for an answer of 11.52. For the second step, I need to look at our powers of 10. 10 to the 3 and 10 to the 4. When we are multiplying, we've already spoken that when we multiply powers, we start by writing the base and then adding the exponents. In this case, the 3 plus the 4. That's going to give me a new power of 10 to the 7. In the next step, we're going to piece these two together to make one answer. So in step 3, I'm going to take the two pieces we have and go ahead and write our new number in scientific notation. It's going to say 11.52 times 10 to the 7. So here we go. Our answer so far looks similar to scientific notation. Only there is one small problem. We've talked about with scientific notation, our plain number in front has to meet two criteria. It must be greater than or equal to 1, but less than 10. In this case, 11.52 is less than 10. So we're going to go to step 4, where we're going to adjust the number so that it is now between 1 and 10. Here's how we can do that. I'm going to start by rewriting the number below. And now I'm going to look at where the decimal needs to be. The decimal needs to be in a spot where there is only one number on the left side. So I need to grab my decimal and move it one space to the left to now have 1.152 2 times 10. And now I need to talk to you about what happens with the exponent. Notice that with the exponent, it indicated how far did the decimal move. Well, our decimal had to move one more space to the left. And every time we have moved the decimal to the left, it has been because our number is greater than 1. And when our number is greater than 1, our exponent was always positive. So our number is going to become more positive by adding 1 because I moved one more space, making my new exponent an 8. And that is how we multiply using scientific notation. We used an old skill of multiplying decimals and a new skill of how do I multiply powers, in this case, powers of 10. Now let's look at division. So with division, I'm going to write in the problem we're going to use. We're going to say 7 times 10 to the 9th divided by 3 times 10 to the 3rd. I'm going to walk through the 4 steps with you, and each time solving that portion of the problem. I want you to notice something. The steps are very similar to the steps for multiplication. The only difference is, since we're dividing, we of course need to divide the plain numbers, and then when we go and do our powers of 10, since we're dividing, we must subtract. But let's take a look. I need to start by taking 7 divided by 3. If you need to, it does not hurt to do it by hand. 3 can fit into 7 2 times, leaving me a 1. I'm sorry, backtrack. I apologize. We all make mistakes. 3 times 2 is 6. I subtract. Now that leaves me a 1. I place a decimal in a decimal so that I can write my 0. I bring it down for 10. 3 can fit in the 10 3 times. For 9, I once again get 10, and we're going to stop there. Because remember, these mean we're repeating. So we're going to repeat here. So our answer for 7 divided by 3, we're just going to cut it off at 2.3. Now, let's look at the next portion. It says to subtract the exponents on 10. Since we're dividing, we learn that when we divide powers of the same base, we start by writing the base and then subtracting the exponents. Once I follow through with that subtraction, it is now 10 to the 6. Now I'm going to go ahead and put those two pieces together. I'm going to say first my whole number piece, or plain number piece, because it's not a whole number, 2.3 times, and now my scientific notation, the 10 to the 6th power to get a full answer of 2.3 times 10 to the 6th. Step 4 would be to adjust the number to be between 1 and 10. But here, since there is only one number in front of the decimal, and that number is greater than or equal to 1, but less than 10, our number is already correct, and our answer will stop here. Now let's jump over and look at adding and subtracting. Now for this one, I'm going to start by giving you the steps first. Here, we're just going to have 3 steps. First, I want to take each number, each piece, and write it in the standard form. Meaning we're going to write it so that it no longer says times 10 to a power. Next, we will add or subtract depending on what the problem is asking. And then we will put our answer back into scientific notation. Let's go ahead and apply those 3 steps to this example. Pause now and finish writing if you need more time. All right, so to start, I need to rewrite this in scientific notation, or in standard form. I apologize. Let's do that first. Let's first take 6. Oh. I apologize for that. We're going to first take the 6.89, and I'm going to move the decimal 1, 2, 3, 4 spaces for a new number of 68,900. And then I'm going to go do the same thing for the 9.24. It's to the 5th power, so 1, 2, 3, 4, 5, and then fill in my zeros for the new number of 924,000. And now I've completed step 1. I'm going to go and write these pieces now in standard form. We want to solve 68,900 plus 924,000. Now I'm going to note, I said something incorrectly when I read that number. I put that "and" in there. That is not actually part of how we read the numbers. But it goes to show you, even math teachers make mistakes. When I go and add this together, you can check the math off to the side, but you get an answer of 992,900. So step 2, we added them together. And now for step 3, I'm going to change this to scientific notation. First, let's move our decimal from the end. 1, 2, 3, 4, 5 spaces for 9.929 times 10. And we want to look, our number is 992,900. Well, since that number is greater than 1, our exponent is positive, So our exponent will be positive 5. Now we're going to do one more example, and that will be of subtraction. In subtraction, we're going to follow the same 3 steps, so you don't need to write them down again. I put them on top of the page as a quick reminder. First, let's write the 2 pieces in standard form. If we write out the first number, 7.83 times 10 to the 8, in standard form, we get 783 million now minus, if I write out the second number, it is 11,610,000. Now I can perform my subtraction. Off to the side, I want you to verify in your notes that I am doing the correct subtraction when I get the answer of 771,390,000. And now I'm going to change this into scientific notation. When we look at this number, I said 771 million. Think we can agree that this number is greater than 1, so I'm going to have a positive exponent. So when I move this 1, 2, 3, 4, 5, 6, 7, 8 spaces, I'm now going to say 7.7139 times 10 to the positive 8. Now I'm going to flip the page and give you 4 examples to try out, one of each problem. Take a moment, write them down, pause the video, and then come back and check for the solutions. Here are your 4 problems. At this point, pause the video, copy them down, and then check back for the solutions. Here are the solutions to those 4 problems. Take a look at them, and if you have any questions, bring them to me in class or after school.